Everyone. My name is Shervin Shahidi. I am the CEO of the Medlin Group, and it's my pleasure to warmly welcome all attendees who are poultry specialists from leading farms across the Middle East to this important session, which is scientific. I would like to introduce a little bit about the Medlin Group. Medlin Group is a trusted name in the veterinary pharmaceutical and feed additive industry with over 25 years of experience, delivering high-quality, field-oriented solutions. Our portfolio includes more than 80 products from 16 European manufacturers across France, Spain, Romania, and Argentina. We are active in the UAE, Oman, Qatar, Bahrain, Kuwait, and also Iran, offering advanced products across 7 distinct therapeutic and nutritional lines, which are nutritional products and heat stress management, gut health and immunity, growth and performance, and disinfections and biosecurity. Our core value lies in delivering farm-level solution through quality-oriented, science-based product tailored to the real needs of modern poultry production. With that, I would like to introduce now Professor Dr. Alexandru Baciu, Technical Manager of Delos Medica, the European manufacturer of the ProBio Synergy. He will now begin the scientific session and share more on the novel immune-based approach we are focusing on today. Alex, please.
Good afternoon, ladies and gentlemen. I'm very glad to be in front of you and to try to present one of the most interesting products we have in our portfolio. Basically, I want to present myself and tell you that I'm a veterinarian. I graduated 41 years ago in Bucharest, Romania. I had the opportunity to work in the field, in poultry industry, other farming industries, pets. So from 2013, I joined Delos Medica, a local manufacturing plant that it's mostly involved in antibiotics and antiparasitical production, but also in some distribution onto the domestic market. After my arrival here in Delos, we could see that year by year there is a trend in mostly in Western countries and the United States, and later on in other countries as well, in restraining the volume of the antibiotics that should be administered on the market. Firstly, only discussing, after that, acting in monitoring all the usages of these antibiotics on the market. Obviously, this was linked with the resistance against the antibiotic that was also influencing the resistance from the breeding industry in the human health. So this problem became bigger and bigger and lead to decreased volume of sales in antibiotics on the whole world, the whole market. And obviously, for that, the reason we need to replace some gaps with other options in controlling the gram-negative, especially, well, generally the pathogens, germs that are creating big problems in the industry, farming industry. So obviously we could see with our own eyes how the companies try to prevent the gram-negative effect by administering acidifiers, by administering other chemical compounds like peroxides into the water. by using prebiotics, probiotics, postbiotics. So basically, we tried all the ways to control the pathogens in the farming industry. And step by step, we reached a level when were looking for new approaches. In this respect, our new approach is to put the immune system to work, helping us not by vaccination like it was up to date, but by asking and cheating the immune system to conform with our requests. You'll see in the next slides I shall present you that this is possible. Our product called ProBio Synergy, it's working like that. But firstly, I would very much like to ask you to have a little bit patient and to look to some slides where I shall try to explain about the immune system and the answer that the immune system is giving to us. And speaking about some mechanisms, specific mechanism of the innate immune system, because the immune system has two sides, the innate immune system and the adaptive immune system. Okay, so let's go. I discussed about the way that the whole world tried to reduce the usage of the antibiotics. It is out of the question that this is a trend that will continue. So we have to be prepared ourselves to use other methods in controlling the germs in the farming business. As you know, the immune system consists in organs and in cells, and also in the results of their work, antibodies. From all the organs of the body, in poultry, the intestine contains the most numerous lymphoid tissues. Lymphoid tissue, it's an immune tissue. Lymphoid tissue is the most important part of this factory where immune system is it's starting to answer to all the problems that the germs are starting to create in the body. The workers that are creating the antibodies are the plasma cells. And it seems that 70% from the plasma cells are found in the intestine mucosa. It is such a big activity there as the production of the result of their production, that it's IgA, the mucosal antibodies, are the production of IgA surpasses the entire production of the rest of the organs that are producing antibodies like IgG 3 to 5 times. So let's speak a little bit about the morphological structure of the intestine. That's because, as I told you, 70% from the lymphoid tissues are around the area of the intestine. So what we have here, we have physical barriers, and we have lymphoid follicles that are well organized. We have lymphoid follicles that are isolated, aisles along the intestine. We have diffuse lymphoid tissues that it's not organized as follicles, but a bunch of cells in different areas. And also we have these mesenteric lymph nodes that are also part of the barrier that it's trying to keep the infections as far as possible from the body. The epithelial barrier, it's covered also with the mucus. The mucus is produced by some specific cells that are everybody on the different mucosas that are covered by mucus. This is very important tool of keeping away the germs, and also to protect the epithelium from different situations when it is attacked by noxes or other chemical compounds. It is very important to know that mucus has two layers. One of them, it is intimate in contact with the epithelium cells, and the other is in contact with the content of the intestine. The first one, it's more fluid, the one that it's in contact with the cells of the epithelium, and the other one is more viscous. The layer that it's in contact with the content of the intestine is populated with different germs, could be populated with different germs and different parts of the feed. But the other one that it's in contact with the epithelium shouldn't be populated with any cells. Also, there is in this epithelium, also besides the epithelium cells, there are some specialized cells that called Paneth cells that are excreting some substances, some peptides with antimicrobial effect. If we are looking at the whole digestive tract, starting in the mouth and up to the end of the cloacal bursa, we can see that we have along these tractus different organs, pharyngeal tonsils at the beginning, continuing with other tonsils, and of course after we are starting to watch the intestine, we have these PIR patches with an extremely important role in the immune response. Also, other lymphoid tissues along the whole intestinal tract up to the end of it. This is extremely important, and this is basically, you can look at these line along from the peak to the end to the cloak, that we are like on a front line. A front line with the units and subunits that are ready to interfere with the germs and to destroy them. Also, what we have here, we have the physical barriers that should be understood, that beside the epithelial surfaces, we have physical movements of like peristalsis or ciliary motion of the epithelia, that are trying to remove the content of the intestine, that it's full with microbes, with germs, with pathogens. And also, together with the mucus, we can say that we have a strong physical barrier that the organism it's using at every second against the germs. Besides that, we have another barrier that consists in the gut microflora. The gut microflora, it's extremely important because when they are together with pathogens, they have to defend themselves. In order to defend themselves, they have different mechanisms. They are producing some antimicrobial compounds called bacteriocins. These bacteriocins are acting like antibiotics, and are trying to destroy the gram negatives that are competing with the normal gut microflora. We have also this competition not only not only by excreting the bacteriocins, but also by occupying sites, attachment sites of that are needed for the gram-negative pathogens to attach to the epithelium. Also, during their life, they are determining in their close surroundings a lower pH, an acidic pH. It is to be understood that in the intestine, the environment is alkaline. All the bacteria that are normally living there are used to live in an alkaline environment. The creation of an acidic environment, it's disturbing a lot, and it's slowing down the development of the division of the cells of the gram-negative pathogens. So that's why what we are doing, we copied basically the nature. We are using acidifiers for the same purpose, to put into contact, to put all these gram-negative pathogens that are used to survive in an alkaline environment with an acidic environment that is slowing down their development, and this way we can control. It is to be understood also that the gram pathogens are not disappearing. Everything we are doing with antibiotics, with other substances, with other modes of action, they are not disappearing. But the whole purpose is to maintain them at a controllable number. If they are reaching a number and exceeding a certain number, then we can see different clinical signs, the disease, yes. But if they are not exceeding that level, certain level, we are controlling them. That's the control. And all we are doing is to control them to be under a certain number, to depress them, not to exceed a certain number of that is creating these clinical signs. Speaking about the immunity, we have, as I already tried to tell you in a very few words before, we have two kinds of immune system in our body. One of them, it's innate immune system. The innate immune system, it's an immune system that appeared a very long time ago during the evolution. It was the first way that the life beings tried to protect itself. This innate immune system, it does exist in our bodies, even in human bodies, and it is a defense strategy in vertebrates. The key function in innate immune system, are very important. First of them, and the most important, I think, in my opinion, it is to recruit immune cells to come to the sites of infection. These immune cells, if are coming there, are starting a procedure that in the end of the day will lead to the production of antibodies, specific antibodies that will protect the mucosa. And also they will activate immune responses by facilitating the start of the activity of the adaptive immune system. The adaptive immune system, it's appeared very late in the evolution. And what's very important is that it's a complex of cells, organs, and processes that are creating specific response adapted to every specific pathogen they are working against. Key functions. First, to provide highly specific response against the enemies. Second, to generate immunological memory. As you know, the innate immune system is not creating an immune memory for a long term, but only for a very short term. That's why when we are using, for instance, vaccination, we are using vaccination with live vaccines for having a fast response. But if we want to have a long immunological memory, we are going with inactivated vaccines in order to force the adaptive immune system to create this memory. This kind of adaptive immune system is using very specific cells, and these cells are assuring a long-lasting protection. Basically, the adaptive immune system, the discovery of the adaptive immune system, it's determining the foundation of vaccine strategies. What I want to point here is to show that innate immune system, it's the duration of his reaction and the response in antibodies is in hours, but the adaptive immune system needs days for that. So all together, when they are acting together, so we can have a reaction on short term by innate immune system, and the reaction on long term with the immune memory on long term. Immune response, it's basically possible because there are some parts of the germs called PAMPs, pathogen-associated molecular pattern, that are recognized by some receptors. So we have the germ that it's recognized all together or part of it by receptors. These receptors are two kinds of them: the pathogen-associated molecular patterns or toll-like receptors. These two kinds of receptors are essential in determining our immune system to give an immune response. Let's clarify a little bit what means PAMPs, or what are these PAMPs. It looks complicated, but it isn't. It is the fact that, let's look at this picture. What you see here, everybody will say it's a house. Yeah, it's a house because everybody knows the roof, everybody knows about the windows, everybody knows about the shapes we can see here, and we are saying it's a house, but it's not a house. It's a draw. It's part of a house, has some components of a house. So PAMPs are components of the germs. So basically, you can recognize the body can recognize only the roof, or can recognize only the window, or can recognize only this shape, and he will know that this is the germ. So depending on the type of receptors, they will react. So as I told you, we have the possibility of recognizing different parts of the germs by different receptors. I told you that we have two important categories. The pattern recognition receptors are extremely important because in our case, for us, for our product, are extremely important because part of them are the so-called peptidoglycan recognition proteins. Peptidoglycan recognition proteins as is this their name, are recognizing peptidoglycan. And we shall speak a little bit later about this peptidoglycan, what it consists in and what is its role. The toll-like receptors are extremely important as well. They can detect microbial components, and this is extremely important, and they are present on the surface of some important cells we shall discuss about, the so-called dendritic cells that are starting the process of the immune response. As you can see here, that following the recognition of the PAMPs by the receptors, it's starting a complex immune cascade response process. And the end of this process is the production of IgA antibodies. These IgA antibodies are antibodies that are protecting the mucosas. They are present everywhere. But the most important part for us is that they are protecting the digestive mucosa. The digestive mucosa against whom? Against the pathogens. So what we have here in the picture you can see here, it is that we have the epithelium. Yes. We have the mucus. Yes. The mucus is sometimes, in case of infections, populated with bacteria. Yes, you can see them here. And from the mucosa, we have some structures that are the basement of the immune response, respectively the lymphocytes T and lymphocytes B that are present in the PRRs patch we discussed about before, that are lymphoid follicles present in the structure of the digestive intestinal mucosa. What is very important, it is these cells you can see here that are the dendritic cells. These dendritic cells are capable to circulate in the system and to go outside the epithelium and to make sampling of the content present in the mucus. So basically they can recognize with the toll-like receptors, they're recognizing parts of the bacteria that are present there. They are taking samples. They are taking them inside. They are digesting and are presenting the result to the lymphocytes T. The lymphocytes T basically are activated and are sending the messages through special chains of amino acids called peptides. And in immune system, these peptides are so-called cytokines. So they are communicating these lymphocytes T with the lymphocytes B. And due to this message they are receiving, the lymphocytes B are transforming themselves into the plasmocytes. The plasmocytes are basically factories of antibodies, IgA antibodies. So basically we have recognition, we have a capture of the dendritic cells. I'm speaking about the capture of germs. We have digestion, we have this presentation. That's why dendritic cells are so-called presentation cells, immune cells, are presenting the results to the lymphocytes. Then lymphocytes are communicating with the lymphocytes B, T. Lymphocytes are so-called T helper lymphocytes, are communicating with the lymphocytes B. that are transforming themselves into plasmocytes that are producing IgA. It's a very interesting chain of reactions. It's a flow of production that is fantastic. ProBio Synergy. ProBio Synergy, it's our product that it's working like you could see before. Yes, the same logical flow of immune response. It's in this case, it's starting with the administration of ProBio. What is ProBio consist in? The composition of this product, it's very simple. It's a sort of a D-Glucosamine. D-Glucosamine, it's an amino sugar. So it's basically a sugar where one radical was replaced by amino radical. So besides that, it's purified water. As you can see here, we are speaking about D-Glucosamine modified. So D-Glucosamine modified, it consists in glucosamine, that it's basically hydrolyzed chitin source from a crab, filtered, and later on by bioengineering, we are linking on the, okay, so D-Glucosamine is the green part, you can see here, and through bioengineering, we are adding some peptides, the brown ones. This is an alkylation process where every molecule of D-Glucosamine, it is linked with small chains of amino acids, peptides, and this way we are creating a pump. A pump, respectively, a part of a germ, a pathogen that basically looks like a big danger for the body. We have here a draw of gram-negative cell wall. Basically, this is an E. coli cell. What you can see here, you can see the vegetative cell, yeah, that have the nucleus, cytoplasma, the membrane, and what you see here, very thick, it's the wall. The wall of the gram-negative, it's for protection. It has 3 layers. It is a layer that it's in contact with the membrane. It is an intermediate layer, this one, that is the most important as volume. This intermediate layer is so-called peptidoglycan. We just discussed about, and very important is that this peptidoglycan is common to all gram-negative. It has the same structure in all the gram-negatives. This peptidoglycan, it consists in alternative layers of 2 acids. It's N-acetyl D-glucosamine and N-acetyl muramic acid. Basically, these 2 layers are linked together through peptides. Peptides consisting in 3 to 5 amino acids. Very important is that basically our product consists in D-glucosamine plus the peptides. So basically our PAMP, it's imitating part of the components of the peptidoglycan of all the gram-negatives. We have here with G, it's glucosamine, and with brown, we have here the peptides. So basically, we are giving to the birds this kind of PAMP, yeah, that it's D-glucosamine plus the peptides. The peptidoglycan in gram-positive cells, it's, as you can see, much more thicker than in gram-negatives. That's why the gram-positive are cells, microbes, vegetative cells of the microbes are more resistant in antibiotic than the gram-negative. We have here the peptidoglycan that, as I told you, has two layers, N-acetyl D-Glucosamine and N-acetylmuramic acid, linked with peptides. And our ProBio Synergy, it's a product that it's offering to the birds part of this structure of peptidoglycan and as a pump. So what we have here, we have receptors that are recognizing the peptidoglycan. We have dendritic cells that are becoming mature and are sampling the antigen. And we have the presentation of these cells to the lymphocytes T, helper, that are inducing after that the immune response by transforming lymphocytes B into plasmocytes that are producing IgA, specific IgA. That's very important because it's the first time when we are speaking about a specific response, not a general response like it's happening in antibiotics or in other substances like peroxides. Yeah, they are killing everything, the peroxides. We reach here a moment when we should discuss about trials. The trials were performed in our country and in some other countries with let's say, Mediterranean temperate climate, not very hot like it's happening in Emirates. So that's why we are strongly considering that the trials with this product should be performed in different type of farms from Emirates. And I'm sure that Madeline will be deeply involved in this action, organizing trials all over the Emirates. Initially, this product was created for controlling Salmonella. Salmonella, as you know, it is a very important pathogen that is creating problem in human health. So Salmonella enteritidis, it's one of these problems, and we made a test where we took some batches of poultry, broilers. We administered one dose. We shall discuss about the way of administration. Just take it like it is, one dose, the first dose in D-Day. And 2 weeks later, like a vaccine, we gave them a booster, the same quantity of the same dosage. And 3 days later, we performed an experimental infection with a big quantity of Salmonella enteritidis. And after that, we several days after, we sacrificed the chicks and took samples. It is absolutely clear that we had two flocks, one treated, one untreated. And we compared after sampling, we compared the presence of Salmonella in both flocks. What is extremely interesting is the strong reduction of the blue column against the green one. The green one was the control that were infected, and the blue one was the treated flock. And we can see that in only 2 days, later, after experimental infection, we have about 10 times lower quantity of Salmonella in the infected chicks. So this shows us that the product works very well. And why? Because it has tools to fight against the Salmonella. We tried other tests in layers. Of course, sorry. It is well known that the longest is the duration of the technological life of the bird. Bigger is the possibility of infestation with Salmonella. Layers do have a very long life, technological life, so very often in a lot of farms there is a frequent occurrence of the Salmonella according to the duration of their technological life. It seems that nowadays, even if initially the flocks were supposed to be in the production till 70-75 weeks old, now there are a lot of companies that are checking the profitability of maintaining the flocks, and they are keeping nowadays up to 100 weeks. So if we have problems at 70 weeks already, just imagine what's happening between 70 weeks and 100 weeks, the possibility of infestation, yes? So we test our product in a company that had in the past occurrence of Salmonella infestation. So we decided not to make any artificial challenges in the farm. There were farms, that was a farm where we worked under the production conditions. So after we used our program, I shall present our program later on, and the result was 100% negative Salmonella. Even if in the history we had a very frequent occurrence of Salmonella. We have here a better status of health, that it's measured by the mortality, that it's half of the historical average. We have better uniformity in eggs, that it's consistently better. We have a bigger weight gain at 14 weeks. And in the end of the day, we realized that the feed conversion was better. And, you know, feed conversion means money. So in the end of the day, we considered that this was a very good and positive trial. We made something on broilers as well. And we have here two houses compared, the house number 4 and house number 12. What is very important is that in Romania, we are comparing the technical results, so technical parameters, by using a so-called EU index, European Broiler Index. This is a parameter that consists in a formula where we are introducing the average daily gain, the survival rate, so basically the mortality, and the feed conversion rate. So in the end of the day, every production, every flock is followed by an index that shows us how the flock evolved during the technological life. And in the end of the day, if it is efficient or not, or how efficient it is a flock in comparison with another. So what was very good in our trial was that we had a better average daily gain, and we had a better, let's say, European index. That means money. Every percent, every point from European index means a lot of money. So basically, even if in this category, in broilers, the possibility of infestation with Salmonella looks somehow smaller than the possibility of infestation is smaller than in the laying or breeders' hens. Anyhow, the infestation of the meat, it's a disaster. With Salmonella, it's a disaster. So all the breeders are trying to avoid this by introducing in the feed a lot of ingredients against or that could control the Salmonella. Our product, it's a solution in this respect. And what is most important and what where we can win, it's in the gut health. The gut health that it's described by the results of the necropsies. We want to have these healthy mucosas that are extremely important for the results, the zootechnical parameters, the results in the end of the day. I mean, the feed conversion, the average daily gain, the weight at the slaughterhouse, the average weight, and so on, mortality. So this is what we want to see: clear organs, healthy organs that could help us in obtaining very good results and money. In the end of the day, we're speaking about money. That's it. A good sign is also the bursa uniformity. We have here the measurement of the bursa, and we can see that we had healthy birds. Speaking about the application and the dose of application. This product, as I told you, it's to be used in all the categories, starting with broilers, continuing with laying hens and breeders. And depending on the category, we have different programs. In broilers, we are strongly recommending to start the first application, that it's in broilers 0.2 ml per head, like a vaccine, a dose like a vaccine, yes? Starting in day 7. Why? Because up to day 7, the birds cannot have an immune response. Only after day 7, their immune system is well developed for starting and responding to these contact with different antigens. We are giving later, 2 weeks later, 14 days later, a booster. That is with the same dose, 0.2 ml per bird. So basically we have 2 administration, day 7 and day 21, let's say. And this way we are sure that we have a protection up to the end of their technological life. If we are speaking about other categories like layers, here we have different situation. But if we have the clearest one with starting from the scratch, with when the production is starting, we are starting in day 7. We are continuing the booster like in broilers 14 days later with the same dosage. But because of their life duration, we are interested in obtaining some more things than in broilers, and that is particularly because these birds have after 14 weeks they are again vaccinated and sent to the production houses. We want the body to respond very well, and this product, particularly, it's well received because it's creating a booster in the immune system, the whole immune system. So this booster, it's perfect for our purposes when we are is followed by a vaccination. So we are making a booster in week 14 or 13. It depends. I don't know when you are scheduling the vaccination before the transfer of the birds to the production houses. And after that, several days after, you are making the vaccination. It's perfect. This booster, it's increasing the immune response, and this is basically, as you know, followed by a good status of health and a good curve of production. We have to remember to the birds this lesson. So we are coming back with a fourth administration of product at 45 weeks old. After that, we could discuss if it is necessary to remember them again, depending on the decision of maintaining the birds up to an older age or just like up to 65 to 70 weeks. If we are intending to maintain the birds more than this age, then we have to remember them about this problem after 55 weeks to 60 weeks, and to restart, let's say, to make a restart. So we can go further with a new administration of 0.4 ml per head and see what's happening, how much the birds are kept there. Anyhow, we could have other options. For instance, let's say there is a farmer that has the birds of 20 weeks. They have basically started the production, but he wants to start. He is afraid about Salmonella, so we are starting from scratch, like having a bird that it's naive, has no experience and immunological experience. So we are starting with the first administration of the dosage repeated in 2 weeks later, a booster. And after that, to go to 45 weeks again. And later on, depending on our purposes, what we want to do, to administer again or not, depending on their technological life. Or we just have old birds already, 50, 55 weeks. So, and we are intending to maintain these birds for a while to see what about their curve of production. So we are starting at that age from scratch. First administration, 2 weeks later, and after 14 weeks, if necessary, if they are still maintained, a third administration. So this is very fluid, depending on the situation of the birds. Starting from scratch, from the very beginning, or starting later, or very late. It depends on this their age. But as you can see, there is a pattern. Always it's a beginning and a booster after 2 weeks. And after that, we can see depending on the category. Thank you for your valuable time, and I'm waiting for your questions if you want.
Thank you very much, Alex. Thank you so much. Again, thank you very much, the attendees, so much. Hope that the information was and is useful. Now we arrive to the question and answer session. There are 2 ways of asking the question. One is you can write in the webinar chat your questions. It will be answered. Or in case, you can raise your hand and we can allow the people who raise their hand to ask the question and talk with the professor. Thank you very much. Okay, Richard, please arrange with Dr. Rahim, please.
Okay, so Dr. Abdul Rahim is asking, are there any novel delivery systems like nanoparticles, oral encapsulation being explored to enhance mucosal immunity in commercial flocks?
In our company, no, we don't have these plans so far. We are trying to, we have other projects, and you know, there is a huge amount of time we need for these researches. So no, we don't have this type of oral encapsulation plans and studying.
I
No.
think, Alex, doctor asked about this product. Is there any especially drug delivery or delivery system has been used?
Okay. Sorry, I did not understood very well. It is not necessary. This is because this product is not sensitive to, let's say, pH, low pH, like in the stomach, and we need it to be present from the very beginning of the intestinal tract in the mucus. So basically, these encapsulation is for protection, but this product is not affected by the low pH. In nanoparticles, no, sorry. No, there is no drug interaction with our product. It's as I told you, it's basically it's like part of peptidoglycan, yeah, of the gram negatives.
Okay.
It has no interaction. It's not interfering in the metabolism of the antibiotics or other drugs. It is not. Exceeding the intestinal tract. It remains there, and only samples of it are introduced and digested by the immune cells, dendritic cells.
Alex, now I have a question, a short question. That is, what about is any interaction with the vaccines? Maybe this would be a question in future or now with the attendees.
Sorry, could you repeat the first part of your question? What is
I
about?
asked about the interaction of the ProBio Synergy with vaccines.
Okay. What we are doing? So first, both ProBio and ProBio Synergy and the vaccines are addressed to the immune system. After we are administering them, we are waiting for an immune response. Both are giving a specific response. I mean, IgA specific for peptidoglycan in ProBio case. Obviously, in the vaccines are more specific because they are against some specific viruses. We are giving to both, in both cases, 2 doses. I mean, if we are comparing our product with live vaccine, at least 2 doses, depending, like in also in the vaccines, depending on the category of the birds. In broilers, 2 doses. In vaccines, 2 doses in ProBio. In laying, we are giving 4. At least 4, yes, like it's happening in the vaccines, like IBD, yeah, probably that we are using live IBD vaccine till 45 days. So in this respect, we can say we can compare. It is not a vaccine, obviously, but we can compare the way of action and the mechanism and the administration and the expectations with vaccines, live vaccines.
Gentlemen, any questions? We are here to answer you and explain about everything. Please. Okay, thank you very much. It seems, as far as I see, no question is remain, and the subject was completely clear. We truly appreciate your presence here. Thank you very much again on behalf of all team from Delos Medica and Medlin. I would like to highlight that after the webinar, we will make some steps as we prepare the thanks to the physical certificate of participation, which will be issued for all attendees, include the company name, and will be presented face-to-face, which is appreciation. All the session has been recorded, and we will prepare the recorded session to the gentlemen in attendance. And we will try to provide, again, the product information and the presentation in PDF of this session. I'm thanking you so much, and thanks my team and Alex, Richard, Abdallah, and everyone. Appreciate it, and thank you very much. We'll see you again face-to-face for another webinar. Thank you very much.
Thank you.